On behalf of Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur, I would like to welcome you all at this Saturday Manufacturing Talks. As you know that this is a mega webinar series. We have started in the month of March, and today is the 22nd, the Saturday, 22nd webinar. And for the last 21 webinars, we have, experienced the wonderful lectures on different aspects of, the manufacturing. It was there in the field of additive manufacturing, digital manufacturing, modeling and simulation, and so on. So today also, we will be experiencing an interesting topic, which is the resilience in the field of the manufacturing. How much smart our manufacturing industries are. We all know that the pandemic has grossly hit us, whether it's our personal life or the industrial sector. Now the shop floor managers are, they're looking back, they're thinking whether had it been possible for them to come up with the different products with the same, the supply chain systems because of the, these pandemic situations and all. So, and when they look back, they find that innovation is the key. Innovation is the key to meet up the expectations of the, the marketplace, specifically for the Indian marketplace. The beauty of the Indian marketplace is that we demand both. We want the, we do have the budget constraint. At the same time, we want the smarter and the smaller products. So, is smart manufacturing really smart? And what is the need of the frugal engineering to make it smart? So we'd like to hear all these from, the renowned speaker in this field, Professor Ajay Malshe. Professor Malshe is R. Eugene and Susie E. Goodson Distinguished Professor at the School of Mechanical Engineering, Purdue University. He has 25 years of academic scholarships and 15 years of partly overlapping nano-manufacturing business experience, taking breakthrough ideas from the tabletop to factory floor as founder, CTO, and board member of Nanomake Corporation, which is now named as FinTech Nanomaterials. He is a member of professional organizations including ASEE, ASME, CIRP, NAE, and SME, and serves various roles there. Subjects of his competencies are human-centric convergent manufacturing, bio-inspired designs, multifunctional materials, and system integration. Application areas of his experience are heavy-duty machines, microelectronics, smart food manufacturing for EPT, and in space manufacturing. That means it covers everything from the heavy engineering to the nano to the microelectronics. He has 27, the patents which has been, either published or just filed. More than 60% are licensed, resulting in commercialized products for leading aerospace, automotive, specifically in the field of electric vehicles, energy, heavy-duty trucking, racing, and other industries. Malshe received more than 40 international recognitions, including a member of the National Academy of Engineering, SMU Research Implementation Award, and the 20 most influential professors in smart manufacturing recognition, and fellowships of the American Society of Materials, the International Academy of Production Engineering, and the UK's Institute of Physics. He has trained or mentored more than 1,200 scientists, engineers, and entrepreneurs. With this, let us go ahead and let us listen to Professor Malshe. What is his thought regarding the frugal engineering to tackle this, this sort of situations? Professor Malshe, over to you.
Well, thank you, Professor Paul. This is my first interaction with IIT Kharagpur. So it is really a pleasure, and I appreciate you inviting and share opportunity to share with you. Also, I want to thank all your co-hosts who has been very helpful in logistics, and all the people on the call. I know this is late hours on Saturday, and especially on with that, thank you for your interest in the subject that matters to all of us. Many a time, the talks are designed such that I will be speaking about my own research topic, and I will be talking about results, discussions, and all those. But in today's, I have a combination of multiple things. So I hope you really get some, what I would say, thought-provoking ideas. That's what my intent is. On Saturday late hours, I do not want to bore you down with the graphs and pictures and numbers and so on and so forth. So I thought something that mattered to all of us, especially as we are learning still in pandemic. And so I hope you can see my slides at any point in time. If you have any difficulty because of connectivity, please let me know. I'll try to keep my talk for about maybe 30, 40 minutes, and then I would love to leave space for some questions. So
Yeah,
the topic I
absolutely.
chose is social innovations through frugal engineering and leadership. The term social innovation is typically as well as frugal engineering and leadership is not discussed in traditional engineering curriculum. In traditional curriculums, you can have subjects like static, dynamic, thermal heat transfer, circuit designs, but these are a very new topic, and that's why I thought this would be something exciting. Also, I'm going to blend in with some of the new type of experimental learning that at Purdue I have built. And I presented last week, I presented it at American Society for Engineering Education. So I'm kind of blending the blend of multiple topic, what I call conversions. So let's start that on that journey together. So as I said, this is what the class that I introduced during pandemic on social innovations and social entrepreneurship during COVID-19 pandemic. My research scientist, Dr. Bapat, he's a graduate of IIT Kharagpur, and he and I really presented this together. In a brief, and first, thank you for your generous introduction. But I have been in profession for long enough time, taken the technologies, built the factories, been in the race car. I love competitive racing myself. So been in many disciplines, but today where I am, my core competencies for my research group called RISE, Resilient Innovations for Social Equity. We are interested in the biologicalization, bio-inspired, biomimetic, how to integrate biological components or learn from bioinformatics or multifunctional surfaces and materials. The third area is conversion manufacturing, looking beyond Industry 4.0 and socially conscious productization and frugal engineering, and following are the application areas. So with that backdrop of interest, I would like to start with introduction and background. If you really take a snapshot of last many centuries, you find out very incidentally that every century is named behind materials. So you can go from Stone Age all the way to the nano materials age now. But materials are an enabler for one to make products, manufacture them. And so if I plot this together, going from agricultural revolution all the way to the age of conversions, what we are coming to, each vertical is telling the materials and manufacturing. They go hand in hand. But remember, so far where we stand in the 21st century, we have exhausted all x and y axis of periodic table. Pretty serious. Now we are venturing into the new path. That will, instead of now looking at the chemistry, how to look at the size again, nanoscale, where we can tap into the interface of quantum and classical. So very interesting time. This is where we are in smart manufacturing through the areas of materials. The second way to look at it is industrial revolution through traditional ways of mechanization, electrification, computerization, and now datafication. This is where we are. And so when this all progress is happening, we are in the race of automation. Human is in the race with human, or human is in the race with robots. And where we are today, we are reaching to the point of hyper automation in many instances. And these automation is by either physical machine or driven by data. And at some point in time, there is a law of diminishing return. And one need to look at where am I going now? So with this backdrop of journey of our own in terms of the manufacturing, it is worthwhile to look at from the social sciences, what is the triangle of the Maslow pyramid, human needs. Human needs at the foundation, if you look around in the world in the last 1.5 years, the air is cleaner, unfortunately for unfortunate reasons, fortunately clean but unfortunate reasons. Food, there are lines of foods people are waiting for. Water is challenged. The health challenges are staggering. So if you look at the foundation of the Maslow pyramid, we are seriously questioned here. And then we are very excited to go to space. We are very excited that some individuals will want to go to Mars and Moon. And that is all here in self-actualization. In my own laboratory, we do 3D printing of this, 3D printing of that. This is really light at the top here. So the way I started looking at it, that the foundation of the pyramid is getting challenged, where the top is becoming rich. And you can imagine that any house with a weak foundation, house with beautiful trees on the top, would not sustain too long. And that's what really is what I call the resilience challenge. And today I decided to specifically speak in the context of the numbers and facts I know in US. I would request my all audience to correlate that to where they are today in geographical and in the realities. Because the differences don't much change the inequalities because of race, inequalities because of commerce, inequalities because of technology. But when this is all happening, where the foundation is challenge of human life and the tip is getting rich, you would also find out that at the same time, as a manufacturing engineer, I would see the two things are going down. I have acceptability of technology and I have availability of technology. But accessibility is very seriously challenged. Just as simple as internet access. Many children have no education access partly because there is no internet access. Same thing, affordability is going down. So there are 4 A's: acceptability, availability, accessibility, and affordability. The last two are being seriously challenged. So for food, for example, there are areas called food deserts. They're in cities and they're in countrysides, both. So when this all reality is happening, at the same time, you're finding on the top, the stock markets are moving. The people are excited about electric vehicles. The 5G networks are being promoted everywhere. And in the last 1.5 years, the world has produced few trillion-dollar companies right on the top. But on the bottom, there are people looking for food, millions and millions of lost jobs. People in the high schools and the colleges have high stress level and the suicide rate is growing. And the accessibility has to be challenged. So as an engineer, where my role is to translate science for the societal impact, I really started looking that I'm making intelligent and smart manufacturing decision on the top. I'm trying to make a system more efficient. But one very important question at the forefront, am I making it effective? There's always a difference between efficient and effective. I learned in my days that efficiency.
Excuse me, yeah.
Yes.
Professor Malshe, your voice is, they're getting down and down. Yeah. Can you
Can you
please
hear
check
me
it?
now?
Yeah, it's better now. Yeah.
Thank you.
It would be good. Yeah, if you could speak close to your microphone.
I will try to do that. So what I'm finding is now, thank you for letting me know, Dr. Paul. So what I'm finding is now that the smartness, the intelligent, all these words are in question now because the realities in front of me speak otherwise. What they speak otherwise is that what we believe is intelligent, resilient, smart, they are not being proven, the results are otherwise, and believe it or not, the people are paying for this. So the research is largely paid by the taxpayers in most of the countries. So am I serving the society or am I serving myself is a very question at the forefront of it. And these are realities. These are some of the facts that a phone from iPhone, $699 worth of a phone, I don't know how many people with earning of $36,000 can afford. Price of an electric car, Tesla Model 3. At the same time, how many people have access to the stock markets? So if we consider wealth partly as a quality of life, foundation of Maslow pyramid challenge and the affordability seriously, and these are the evidences. This is not my opinion. I'm the student of these realities. And then I started looking in hindsight, and you will find out that at least in the US, there was a large pandemic exactly almost 100 years before. In 1918, the Spanish flu. And during Spanish flu, I think I would really like, as all colleagues, we all take a pause and reflect on this. When which technology has came to the rescue of billions? And you will find out the technology that came to the rescue of billions is a max. And if I'm really intelligent, if I'm really smart in manufacturing, how come the mass is the best technology 100 years later that is coming to the rescue of billions? And these became very disturbing observations for me that I really need to do a soul searching here. I really need to understand where we are because failures are the great examples for learning. And so today is the thought process that I will share with you. That 100 years before, during Spanish flu, the mask was the best technology, and 100 years later in 2020, mask is the best technology that came to the rescue of billions. But at the same time, people don't believe technology. So we can make technologies and innovation, but if people don't believe, if the communities do not participate, then whom am I making this for? So really the question is at the forefront, what is effectiveness of intelligence and smartness in manufacturing? And that's what, after years of my participation in this discipline, became my curiosity. And I learned and I started looking for answers. At the same time, I do want my students to participate in this learning process. So I introduced a class, and these are the examples of what people call social innovations. In today's presentation, I'll share some examples of social innovations that have made some transformational challenge improvements, advancements in one's lives, and that's what we'll be talking about. So, what is resilience? And by the way, at the bottom of this, I provide publications from my group, and you're most welcome to refer to them. So, I'll be happy to talk in the future. But resilience is defined as the intrinsic property of a system, in this case, a society, to resist and slash or recover and slash or adapt to a new and improved state in time and space much smaller than the overall lifetime. And our disturbance, health, earthquake is a pandemic. And how are we responding to that? And that's what is the resiliency challenge research. I've been participating and I've been involved in this requirement say for oxygen in India. And in Brazil, there is a similar requirement. In US, there is a requirement of logistics. So this is no country is escaped out of this. In many ways, the virus is very equitable. So when I say social innovations, I want to quickly let you know that what social innovations I'm talking
Yeah,
about.
Professor Malshe, We are unable to hear you properly. Yeah.
Can you hear me now?
Yeah, it's better now. Yeah. So please speak closer to your microphone as much close as possible.
I will try to do that.
Yeah.
Thank you for letting me. Sorry for the inconvenience of
No, it's
audio.
okay. It's very interesting talk, so we'd like to hear it properly. So please, yeah.
Certainly. So the social innovations that I'm talking about these are the following examples. And in these examples, top left, what you're looking is here. It is electricity less refrigeration part in a pot. And in India, there are urban parts that we find, at least when I was growing up there, they are used for cooling water during summer. So this is the technology in the northern Nigeria used for extending the life of vegetables for farmers. In ice stupa, I'm sure most of you know, is in the middle ranges of Himalaya for providing the water during middle of spring for farming. Microloans in Bangladesh that won the Nobel Prize, and that is for uplifting, especially women, out of the generational poverty and creating a large opportunity space. The liter of light is an innovation from Brazil, then in Philippines, using the plastic bottles with their designs to use the light in multiple shacks, providing opportunity to people. Tom's is shoes of tomorrow. So when one piece of shoe is sold in US or part of the world, one would be provided free to somebody who has no footwear. And Dabawala is more than 100 years old with high accuracy of precision, completely operable by human, no machine whatsoever, and with the highest Six Sigma accuracy. So these are some of the, and there are about 25 case studies. I study them. I study the engineering. What really happened in these and why they were resilient, because each of them, the cost of innovation is less than $100. They have advanced the life of more than 100,000 people. They were very highly integrated in the communities. Very human was a part of that innovation, and they have uplifted people for their life in many ways for food, medicine, connectivity, water, and variety of other things. So in my laboratory, just to give a flavor of this, we are studying similar of them for homeless people, that is weather protection, for morphable housing, or vertical microfarms for providing food, or here I would share with you briefly 3D printing of food as as a part of machine, and for homeless people that or students in this case, one can print food very locally, just like making a small coffee machine. So we are designing 3D printer of food that the food can be provided at what we call the point of care, the point of care. And these are just the few examples from my group. But continuing this message further, we studied these social innovations on multiple merit criteria. And the merit criteria were social innovators. So we study the personalities of the innovators. Then we studied what environment they were embedded in. So most of the innovations were not done in the laboratory. These are we call them community labs. So the laboratories existed in the community. They were not existed in any building or any per se, any research laboratory. There was very simple but very powerful science and engineering principles were involved. The manufacturing principles were at scale, so you can manufacture them right away. And then there was very deep community engagement, and the cost and the affordability of that innovation was very easy for individual to come. So we came up with a model of frugal engineering for social innovations. And when I say social innovation, this is not about sociology, but social innovations are really socially conscious. socially conscious innovations. So first was the simplicity, very simplicity of science and engineering. The second was very locally accessible materials and processes and expertise were used. The third was frugal manufacturing, such as using components off the shelf. Then open innovation, there were no patents per se in any one of these that were applied. Then the participation of citizens, because technologies was not introduced later, the technologies were invested or developed with the community participation. And the last was the maximum effectiveness, not the efficiency, but effectiveness of if innovations were looked at. So these were some of the very unique attributes that we came across almost more than about, I would say, 20 innovations across the world. So with this intent, I wanted students in my class in the last summer to go on this journey to learn about it. This was a kind of a snapshot of the class, the summer session, the days when the students were learning, the objectives, and what student learned, for example, how a day would look like Monday, Tuesday, Wednesday, Thursday, what kind of projects they were conducting, what they were studying from that. So with that all intent, these socially conscious innovations, following innovations we studied: food storage, iStupa, household entrepreneurs, energy for lighting, Project Tom Shoes, fog harvesting net. An interesting thing about fog harvesting net is that one can learn from bio-inspiration. You remember I mentioned that one of the focus in my group is bio-inspired. So if you look at uh, a beetle in the Namib Desert, in the Mediterranean Ocean, around the desert side of Northern Africa, you would find the back of that beetle is combination of hydrophilic and hydrophobic, and that's how beetles harvest fog into water droplets for drinking. Very interesting example. And then last is food delivery. Students studied the case studies of these, they presented in the classroom. This was a very experimental learning, very experimental learning. It was largely driven by two things: compassion for doing, applying engineering for society. And then second, what do you call the inquiry-based learning? Inquiry-based learning. And those were the two important drivers for this class. We studied in the class the employment, the sustainability, what is the need to serve. And then we also had the metric of social innovations, also social impact, new to the targeted group, so how we will introduce the technology to the society. Increases in the happiness, that is something, happiness does not mean having money. Happiness has multiple other criteria. How it addresses a specific point of care need. Is it effectiveness, not efficiency only, but effectiveness and ability to implement and reproduce at scale. That was very important, that it is not an invention that would take next 10 years, 5 years, 2 years to scale up. So scaling up is during the invention process itself. So this is how students produce the quad chart. I wanted my students first to learn in the geographical area where the innovation came in existence, because the innovations has to do with the cultures. And so understanding those cultures for engineering, innovation, and manufacturing was very important. Then the social problem that this is addressing too. Then the social innovations, that how the social innovation, the science was applied for that specific purpose, and then introduction to the leadership. And this is where the servant leadership is very important, which I'll speak just in a minute. This is second importance. I'm sure most of you would know there's a famous movie produced on this innovator. But here, the idea is that I want to get the message to in my class that innovation is not a singularity. It is not produced in the laboratory, but it is an outcome of a process of immersion. So we can make an innovation and a solution resilient if we built in the society fabric as a part of that innovation altogether. And then students takes on the case studies from engineering, from globalization, then from leadership, and then from questions. As I said, this was very much driven by compassion and inquiry-based learning. So going back, engineering, science and engineering. What was the science and engineering applied in this process? It was not in any specific classroom, for example, design, heat transfer, mass transfer. It was really a convergence of all the disciplines. Then second, understanding the globalization, because the world is all one connected. And then how physically and digitally all connectivity can play a very important role in scaling up these all together in the models. Leadership, because many a time the leadership is seen as a subject to discuss in the college of business. But engineers are leaders by their discipline, by themselves, and understanding there are 5 known forms of leadership. I teach that. So we discussed about the leadership role of each of the citizen in this innovation, and then the questions such as what makes a specific solution viable and effective, and why sometimes the great manufacturing technology would fail. And so we understood that in those models as well. Then we spent time in different weeks, learning about what students believe in social innovation. And they have, you are seeing in the second week, fifth week, and the seventh and eighth week, how their own understanding of the social innovation. And when I say social innovation, that includes intelligence, smartness, resilience, all aspects of manufacturing in various ways. And then we did spend time in leadership. And one of the forms of very effective leadership that is seen in social innovations and resilient innovation is called servant leadership. In the servant leadership, there are important models that we have developed in my own research group. First, we have to understand the business is in the culture. So understanding the culture before understanding engineering is very important. Then how to think simple, because thinking simple is the most difficult thing that one can come across. And I can share many examples of this. Then the compassion for the society, because my education is not for me having a good quality of life or my family, but it is about compassion to society, and not pitifully, but really a compassion. There is a difference between pity and compassion. Then change and encourage. So this is called serenity prayer, that one need to have boldness, because your innovations and manufacturing ideas would be challenged. They would fail also, but how to have change and courage and personality that you built around for that change. Then the value of the thesis of your value message, how to do messaging, how to become a good storyteller. Communication skills are very effective and important. And the last is immersion, that I'm not doing the innovation here and transporting there, but how I'm immersing. So how as an innovator, I suffer from that problem. So if I'm working on a food insecurity, stay hungry for 2 days and see what the effect of hunger can do to your mind, brain, and body. And then you really are driven with immersion opportunities, that how am I going to find a solution? And so we studied about how the servantship, though I serve the community, how servantship goes to fellowship and the fellowship goes to leadership. So students studied that during the classroom. The good example of this from India is Mother Teresa. There are many examples that you can study from the available literature. The second good example is Martin Luther King, and there are numerous examples that I can highlight across the world that have made some very fundamental disruptive changes in the community. So really, if you realize that what I'm bringing to you is that really asking a question that what is really smartness means, what is really intelligent means, and how can we couple them to the society that eventually is partly a part of me, part of the beneficiary, but also pays for what I do as the part of the citizenship. So these are the various classes that I mentioned, and the list of pertinent publication, just to let you know. So we also study these. So these are a few example publications from my own research group in, for example, the Bridge, the National Academies magazine, or Smart Manufacturing by ASTM, and variety of others. So these are a few examples of publications as well. But coming back to the thesis of leadership, that it is extremely important that if we are going to develop the resilient manufacturing, the intelligent and smart manufacturing going beyond the industry 4.0, we really need to start thinking that who we are and where we belong, and not I'm working for a factory, or not I'm in a factory, but world is a factory. So students then took time during 8 weeks of experimental learning, developing the mind map. And that mind map is something very important, that how you go from thinking, immersion, messaging, compassion, courage, change, and servantship, and develop the leadership. So this is one of the examples of one of the students. In fact, I just decided to pick this example for this lecture because this student in the past, if I recall correctly, is the IIT Kharagpur graduate. He's at Purdue now for higher studies. But students developed, in fact, these mind maps in the classroom of leadership. And then the student conducted two projects. One, during COVID-19, tremendous amount of false information is fed into the society. So there are one project dedicated for that, that how to track the false information. And the second project was about an intelligent but almost free mask that one can have. Because as I said, the best technology that came to the rescue of billions is a mask, and that mask is one of the very good example of frugal engineering. And so the class projects were involved in the two teams in device-centric digital tracking of false information, and then the intelligent mask. And this is the kind of the background we already talked to you about this, how the project uh, timeline progressed in the 8 weeks. And then these were the guidance for the final projects that what students conducted. These were very fast track. You can imagine that they have a class every day, Monday to Thursday. It is a class very demanding in terms of learning science, engineering, immersion, leadership, projects. So this is very demanding, but by the time they all finished, they had just incredible outcome, and I will share that in a minute with you. So this is how they presented just the quad charts of their final projects, and there are the whole presentation that went with it. These were the kind of the feedback that we got from the students. It fundamentally changed how they see intelligence, smartness, society, compassion, leadership, and engineering. They fundamentally changed how they today approach engineering, how they approach science, how they approach technology, how they see their role in the society. So it was a very fundamental change, and I foresee that this will stay with them in the decades to come, because we have not changed we didn't teach them any new engineering principle per se. We really taught them not what to think, but how to think. And that fundamental change in how to think was, I believe, was very instrumental for them. We also conducted an open house. So we invited some very serious, very well accomplished uh, people in the world that I knew personally. This is a Chancellor Emeritus, National Academy member, highest honor one can have. And we asked them to evaluate how did we do, how students did. We got some good feedback, some good criticism as well. The next person feedback that you're seeing is this is a privately owned, more than $1 billion company, the chairman, the CEO. This is the feedback from him, and he was critical in many ways, but he has about 40 years of experience himself in seeing what works in the real world and what doesn't. So getting that feedback to students from some colleagues and peers, those are not only like me, just one person, but really from across the board was very valuable. And it was very important part that we could have access to the leaderships like those. So with that, at this point in time, as I said, that I would like to leave some time for questions and answer because this is a dialogue. This is not I'm presenting my results and discussions, but I wanted to have some thought-provoking where we are as a society. So what are the attributes of the social innovations, what I call less than $100 in innovation, advancing life of more than 100,000? This is a very serious manufacturing design challenges. I can tell you, we do this in the laboratory and it looks very simple in the front, but it takes a long time to execute down there. There is a 98 to 2% rule that 2% resources invested in invention and 98% return. Very steep ROI, return on investment. No protection of IP, innovations in the less privileged part of the world, rural and urban both. There are impacts at the localized level and there are large impact because this model is scalable across multiple communities. And then there are other parts that go with it in front of you. Now, you remember I told you that in my lab, for many decades, we study bioinspiration, biomimetic, various components of that. So today what I see is that we are the part of the nature, the biology around us. And we are reaching to the point of Industry 5.0, which is the onset of an age of convergence. That this is not in any school, this is not in any college. This is really the convergence of so many things to solve. And the convergence is not about solution. Because many times we get so much molded into the mindset, how can I come up with a solution? But the thing is, it takes a lot more time in really understanding the problem, and the convergence is about the problem more than a solution. And biology and the biological world around us is a very great example of that. These are some of the pertinent examples from my own research group pertaining to design from biology, materials learning from biology, understanding the resilience phenomena with design architectures from biology and nature around us. And so these are some example publications from my own research group. But with that, I would like to share with you what the smartness and intelligence, because I made a big bold claim that smartness and intelligence and convergence exist in the nature. And I'm going to share with you an example of an animal who has a great sense of symmetry, great sense of art, great sense of material removal and organization for the purpose of just survival. So I hope you can hear the sound. I hope you do. But let me play this just a clip for you.
Unfortunately, this small Japanese pufferfish is dull, almost to the point of invisibility. But to compensate, he is probably nature's greatest artist. Grab a female's attention, he creates something that almost defies belief. His only tools are his fins. In his head, a plan of mathematical perfection. Plows the sand, breaking it up into the finest of particles. These shells aren't just rubbish to be removed. He uses them to decorate the bridges of his construction. He can't rest for more than a moment One must work 24 hours a day for a week, or the current will destroy his creation. A final tidy up, and his masterpiece is complete. Nowhere else in nature does an animal construct something as complex and perfect as this. If this doesn't get him noticed, nothing will.
So with this, I would like to come to the conclusion of my talk by sharing a great example, a poet, a writer, the composer, philosopher, social reformer, and a painter. How many billions that one can have? And that what I personally feel where I am today and what my group we do is what we call experimental learning, learning for the purpose. And with that, I would like to thank audience late hours on Saturday and to engage in something that matters and what we can be a part of building a resilient society. Thank you.
Thank you, Professor. Yeah. So it's a really thought-provoking, the lecture, as you rightly mentioned, and you raised the concern like the smartness and the intelligence and its effectiveness in case of the, the today's the society, because the affordability is, as you rightly mentioned, that it is decreasing. Technology accessibility is also reducing and all. So at this stage, what sort of social innovation has to come up? We have given some examples of social innovations like the microloans of, the Bangladesh. We have already experienced that. And also the Dabbawala in case of the Mumbai, whatever we are experiencing. We have given some examples of your, the social innovation related work, having the characteristics of the simplicity, the economic, and also using the locally available material. You have given the example of the fog harvesting net as well. And also at the end, you have talked about the, the role of leadership, to take this social innovation forward. I'm pretty sure that, the audience have enjoyed a lot and there might be some questions in the chat box.